Hey, all, this is Derek, and this is section 7.1, greatest common factor and factoring by grouping. So in this section, we're going to look at two different styles of factoring. Greatest common factor is going to turn out to be kind of like step zero for every factoring problem. We are always going to look and see if there's a greatest common factor, and then if there is, that's our first step. And then after we've done that, that's going to lead to one of these other styles that we'll see in the next few sections coming up. So factor by grouping, we are going to use factor by grouping when there are four terms. So when we see a problem that has, let me pull one up right there, four terms in it, that tells us it's going to be a grouping problem. So that's kind of the two things we're looking at in this section. So factoring, what is factoring? Factoring is the reverse of multiplying. So if I go 2 times 3, that makes 6, right? So that's multiplication. If I take 6 and I break it down to its primes, that's that factor tree, if you might remember these, 2 times 3. So factoring is taking something and breaking it down to whatever parts it multiplies from. I guess that was really awkward, but anyhow. So reverse of multiplication. So when we're looking at this in terms of kind of more algebraic expressions, if we think of the distributive property, so when we had a coefficient out front or a variable out front, we could distribute that through the parentheses and we get something that looks like this. When we're factoring, what we're doing is we're starting with this side. When we're rewriting it, it's like we're doing a reverse distribute, and that is exactly what a greatest common factor is taking out essentially what would be a reverse distribute for the largest thing that would divide into all the terms. So if I'm looking at 4x and 12, what is the biggest thing that divides into 4 and 12? So 2 divides in, but it's not the biggest thing, right? So we're looking for the greatest common factor. So in that case, we would need to say 4, because 4 divides into both of those. So this is like 4 times x minus 4 times 3. And so what I want to do is take this 4 and take it out front. So that's kind of that reverse distribution. So I'm going to bring the 4 out front, and it's going to leave behind x minus 3. And then I can check every factoring by just multiplying. So 4 times x, there's my 4x. 4 times negative 3, there's negative 12. So that is factoring. This next one, still doing greatest common factors. When it leads with a negative, it is very common, not always, but very common to factor the negative sign out with the common 7. I guess I should have stopped it. Notice I'm going to take a 7 out because I have a 7 and a 14. I have to think about, I'm going to go, 7 goes into 14 2 times, right? So I'm going to need a 2 here. So that when I go 7 times 2, I get back 14. But I need to get back positive 14. So that's going to flip the sign. I'm factoring a negative out, so that is reversing the sign inside and leaving it negative. Which is really hard to think about, but if you think of it in the other direction, negative 7 times x, yep, negative 7 times negative 2 does make positive 14. So when you factor out a negative, you're essentially going to reverse every single sign that you're taking that out of. So that's how to work with negative numbers. So for this next one, looking at the 3 terms we have, these two have x's, but this one doesn't, so x isn't a common factor because it isn't present in this last term. Looking at the rest of the numbers, 9, 12, and 15, they are all divisible by 3. So I wouldn't suggest writing this, but I'm going to write it out once more just to kind of show what is happening. So right there's this common factor of 3 in every one of these terms. And so the idea is I'm going to take that out front and then rewrite it as a distribute. So it's going to leave the 3x squared behind, the 4x, and the minus 5. When I'm doing this for me, I write down this 3 and I go 3 goes into 9 3 times, so 3x squared. 3 goes into 12 4 times, so 4x. 3 goes into 15 5 times. So that's a much easier way to actually do it. But the reason that works is because every one of these terms has a 3. So we're literally just dividing the 3 in to see what's left and putting it here. Divided in, what's left goes here. Divided in, what's left goes there. This next one, so this time they also have, so we have 6 and 18. And so you might spot, okay, they have 2 in common, they have 3 in common, which means they also have 6 in common. So 6 would be our largest of the coefficient in terms of what we can pull out of there. B cubed and B squared. I can take 2 B's out of 3 B's because B cubed is like literally there are 3 B's there. B squared is like there are 2 B's there. So I can take 2 B's out of 3 B's. I cannot take 3 B's out of only 2 B's because there are only 2 B's. So the rule with the exponents is you could take the smallest power. So in this case, the smallest power is B squared. So that's going to be my greatest common factor. That is what lives in both of these. So 6 out of 6, that would leave essentially an invisible 1. And I took B squared out of B cubed, so there'd still be 1 more B left there. So if I multiply that back, there's my 6B cubed. Minus comes down 6 times what to get back to that 18 would be a 3. B squared's covered already, and so that'd be it. This next one, so we got, in terms of the x's, we have x to the 4th, x cubed, and x squared, in case that's a bit small to read. So x squared will be our common there. And then 12, 3, and 18. Well, 12 and 18 don't really matter because if it has to be 3, because the only thing that goes into 3 is 3. So if 3 didn't go into one of those, then I wouldn't have a common factor. But in this case, 3 does go into those. So look at the least interesting number, like the smallest one, generally, and that will kind of like be the limiting factor in terms of what you're able to do. So we'll take a 3x squared out. So 3 times 4 would give me the 12. I'm taking x squared out of x to the 4th, so that would leave me 2 in there still. 3 out of 3 would just be invisible 1. X squared out of x cubed would leave 1x behind. And then 3 into 18 would be 6. And then we took out the x squareds. Another good tip is since this is counting down 4, 3, 2, this should count down 2, 1, and then x to the 0 essentially, or just the constant term. If you have x squared number, or x, and then a number, you've messed up something with the powers, right? If they're descending before, they should still be descending when you pull this out. And then this one, so here we got 20, 12, and 4. So again, 20 and 12 doesn't, 4 is the limiting, it's the least interesting of the numbers. And 4 goes into 20 and 12, so we're going to pull out a 4. In terms of x's, it looks like x squared there is my smallest power, and then y cubed, y squared, y, so y is the smallest in y. 4 goes into 25 times, taking 2 x's out of 4 x's, so that leaves x squared. Taking a y out of a y cubed, so that's going to leave me a y squared. 4 into 12 would be 3 times. And then x squared out of x cubed leaves x, y out of y squared leaves y. And then this one is interesting. So this is exactly what I have here. It's 4x squared y. And so what I need is a -1 placeholder, so that when I take and I go and I do my distribute, I have something to multiply to get this back. So I need a -1 there. If this had been positive, then that would be a +1. Okay, so next up is this idea of factor by grouping. And like I said, we're going to see this with 4 terms. So either we've ran into a problem that has 4 terms, or we'll see in the next section, sometimes we can rewrite something with 4 terms and then use this technique. But grouping, 4 terms. Those are the 2 things to kind of tie together in your head for this particular method. This first example here it's kind of set up, it's already been grouped essentially. And it's just to kind of show you how this idea works. If I had something like 3x plus, if I had something like 3xa plus 2a, hopefully it makes sense at this point that the common factor would be a. If I took that out front, I'd have 3x plus 2. This x minus 5 is working the exact same way that this a was. It's just a common factor. It's just now it happens to be a binomial, 2 terms, instead of a monomial, 1 term. But that can happen. It's still common to both of these pieces here, which means I can take it out front the same way I took the a out front. Notice that didn't become a squared or anything, right? We're just taking a out front and then it would distribute back. So here I do the exact same thing. I take x minus 5 out front, and then it leaves behind 3x plus 2. So, and again, not squared because there's only one of them. We would just be going x minus 5 times 3x, there's that piece. X minus 5 times 2, there's that piece. So it's a different way of looking at FOIL. Instead of doing it one piece at a time, you're saying this whole term times this whole term times this. So that's how you do this. What we're going to do with the rest of these 4 terms is we'll have a step where we make it look like this, and then they all finish up that way. So when we see 4 terms, at least in this class, what we do is we cover up the second 2, and for a moment we're just going to focus on these first ones. And let me write this a little bit bigger just so that to make sure people can see. So if we look at these first 2, what is common is the y's. And what we're doing is we're grouping. We're grouping together the first 2 terms and seeing if there's anything I can factor out of there, and then we'll look at the second 2 terms and do the same thing. So for the first 2 terms, it's a y, so I pull y out of there, and I'm left with an x and a plus 2. Okay, so now I look at my next 2 terms, and I go, anything clever I can do here? It looks like there is a 3 in common. And taking the 3 out of here would leave an x 3 times 2 again. So there we're right back to the same place as we're in that last problem. So now the x plus 2, that's our common factor. So we're going to take that out front, and it's going to leave behind y plus 3. So that is factoring by grouping. So I'll do several more examples of that just to kind of get hopefully all the little flavors. But essentially we see 4 terms. We're going to cover it up. We're going to see what we can do with the first 2. And then here's the thing. This is like, intermediate algebra, introductory algebra. So it's always going to match. If you see 4 terms in this class, it's this kind of problem, and it is designed to do this. So once you get this y parentheses x plus 2 right here, you can just write down the next x plus 2 and figure out, okay, what do I have to do to make that happen? Okay, I pull out a 3. Because these are always going to match, because again, the problems are designed to do that, at least in this course. Same stuff, just more examples. Looking at these first 2, we have xy minus x. So I'm going to take an x out of there, and that's going to leave me a y in the first spot. And then in that second one, I'm taking x out of negative x. So that will be like a negative 1. And then again, you can always distribute back, and I encourage you to do that just to kind of double check yourself that you didn't mess anything up. X times y, xy, x times negative 1, negative x, cool. And like I was saying on the last problem, we're going to get another y minus 1 because these have to match. Looking at what I have here, that is exactly what I have, is y minus 1. So the way to think of this is as a plus 1. Times y minus 1. If this had been 5y minus 10, we would have happily factored a 5 out front. It would have been better if I had made that a 5. There we go. 5y minus 5, pretend like that looks like a 5. We would have happily factored this 5 out front and had a y minus 1 there. It's just because there's nothing there, it's that placeholder 1, and so it's hard to see. And so once we're at this spot, there's our common factor, y minus 1, and then x plus 1 is what's left behind. So for this next one, we got 6xy plus 2y. So for 6 and 2, we could take out a 2, and then both those terms have y's. So take a y out front. Here that's going to leave me a 3x and then 2y. That is plus 1. And then here's another instance where what we have is exactly what we need. So we're just going to go plus 1 and then 3x plus 1. Take this out front, and leaves behind the 2y and the plus 1. This next one, so this is kind of foreshadowing things to come in the next section. So when you see this, you might have the inclination to combine the like terms. Don't combine the like terms. They have those split to make it so that you can do it. So we'll just cover up these 2. And looking at 5x squared and 15x, we would have 5x common to both. So 5x times x would get me back to 5x squared. And then to get to that 15, I would need a negative 3. And then 5x times negative 3, there's negative 15x. So this is kind of what I was saying before. I'm just going to write down that x minus 3. And then what do I have to factor out of this to make that happen? Positive 7. And then I always just kind of distribute and check myself. 7 times x, cool, and then 7 times -3, there's the 21. And now this is my greatest common factor, so x minus 3 out front, and 5x plus 7. And then one more here, we got x cubed. Actually, let me write this a little bit bigger with these powers. Okay, so here, x cubed and x squared, the common would be x squared. So that will leave behind x and then minus 5. And again, we're expecting another x minus 5 there, so it could be helpful to write that down, because then I can see I need to multiply this x by a -6. I check that second sign, and a lot of times people write plus right here because of that positive sign. But if you look, we're factoring a negative out, so negative times negative would get us positive. So if you do look, use this sign to help yourself get this one right. And then there's my GCF is x minus 5, and then left behind is the x squared and minus 6.